I'm so sad we had to shut down that music. I apologize, everybody. All right, well, let's get going. First off, let me introduce myself. My name is Brad Smith. I'm a Corporate Vice President of Sales for AMD, and I'm responsible for the Amazon account for the company. And first things first, is there anybody here that isn't fired up about being in Vegas again together? I mean, honestly, I spend many years coming here all the time, right? We come through these for the various conferences, and I typically sometimes at the end, after a while, you're like, man, I'm so tired of this. This is too much. I could not wait. I couldn't wait to get on the plane. I couldn't wait to get here. And I was excited just to be here and just feel the energy again. So, thank you everyone for attending today's session. I really appreciate it. And as well, a special thank you to our partnership with AWS and everybody that we work with there. There was a lot of stuff going on in the background right up until we did this. So that's always hard to do. And, it's just until you see it real time, you really don't appreciate sometimes how hard it can be. But again, we really appreciate the partnership. And for some transparency for this too, the deck really was created more for a virtualized kind of event, right? So I've got some laundry list of notes and stuff in here that I can't even barely see. So some of this, because it's fairly new, I'm going to have to read through it. Bear with me. I'll blame it on the fact I haven't been on stage in a couple years, right? That and the fact I've been with AMD myself about 6 months, so some of this material is also new for me, but bear with me. So, little synopsis of who I am. Not that really matters with this equation, but so I work for AMD now. I cut my teeth. My background is computer science. I cut my teeth at Intel. We used to call it the heart of darkness, and back in the mid '90s, building out the initial, very forward-looking R&D fabs that they're still generating product today. And I cut my teeth in material handling, and then I spent the rest of my career working with companies like Amazon, Microsoft, Apple, IBM Cloud, all the hyperscalers, you can name them. I've got my fingerprints everywhere. And in trying to build out what is now cloud computing, and it's been a heck of a journey, quite honestly, because I work for a damn good semiconductor company, let me put it that way, right? But really, I'm a software guy. I'm a cloud native by nature. So everything I do is kind of through the lens of that. And the rest of it, I'm kind of picking up on the back end, trying to understand some of the mechanics of it. But luckily, I don't need to know everything. So with that said, I'll probably keep this pretty short. I mean, it may only be about 25 minutes. I'll try not to drone on too much. And we'll have time for Q&A at the end. And if there's anything I can't answer, I'll show you where to go and talk to you how to get answers from there. So let's get going. So a little bit about the history. In reality, the history is not very long between the two companies, AWS and AMD. And we're going to talk today about our third generation EPYC processor. We'll talk a little bit about that. We'll talk a little bit about some new releases that will be coming out you'll see this week between the two companies, right? But when you look back on it, 2018 was the first launch of EPYC 1, first gen EPYC processor codenamed Naples. And it came in the form of a general workload, M5A as well as R5A. We filtered out the rest of the portfolio. We then followed up with our second generation codenamed Rome EPYC processor that occurred, I think, in 2020. And just prior to that, we had our first burstable instance in T3A. The thing about it is, we saw a lot of success, really good success with C5A and C5AD. And in addition, not too far after that, we launched the Radeon Pro V520 as well in the form of a accelerated graphics optimized instance called G4AD. So, it's been quite a few different launches, but you notice 2018 was not that long ago, right? I mean, it's not a very long period of time when you think about this. And when you think about the integration and everything that's required in order to become part of the EC2 ecosystem that exists, it takes a lot of engineering effort and a lot of partnership, a lot of relationship building, as you can imagine. And there's always this kind of ebb and flow between the two companies trying to figure out how to fit with one another, right? So understand that. And when you understand that and you say, okay, well, we being AMD, we don't have a massive portfolio inside EC2, understand something that's, as far as we're concerned, it's the very beginning. I mean, we're just starting this journey with AWS. And I can assure you this, that the rate of innovation will accelerate between the two companies together. And we're just now starting to kind of get our stride. And it's exciting. It's exciting. It's going to be a powerful combination between the two. So with that said, first point of information here. There was a blog that was released, I believe it was a few weeks back, on our first preview on a Milan-based instance called HPCGA. And some core pieces about this, I'm going to have to read some information here. So 96 cores of AMD, 96 cores of AMD's third generation EPYC Milan-based processor. But I'll tell you this, what's really exciting about this is the 65% price to perf benefit over comparable compute intensive x86 instances. It's a beast. And you'll notice it's the very first one that's been named HPC, right? And HPCGA also comes with 100 gig of EFA networking, which allows customers to scale out high-performance computing workloads to tens of thousands of CPUs. In addition, of course, it's built on AWS Nitro cards, which means you can use all those available cores to run your code with bare metal-like performance. There's a lot of reasons to be excited about this from our side. As you know, you may or may not know, AMD's a powerhouse in HPC and parallel compute, right? We're no slouch there. We're driving innovation and driving, we are tip of the spear as far as we're concerned in that business. And getting a chance to work with AWS in combining our prowess in that space and their obvious domination in delivering cloud workloads to various entities and customers, it's going to be a powerful combination. And there's, I'm not sure if we talk about it on this slide or not, but there's other innovations that are being discussed, and nothing we could ever talk about, of course, but suffice it to say that there will be a lot of work together as a company in this area. And so I highly recommend you check it out. There's a couple good blogs. The first one is just a general announcement, and then they launched another one that goes into a little bit more detail about some of the performance benefits. I highly recommend you take a look at that. And then also as a note today, let's see, at Caesars Forum Summit 228 at 3:15 to 4:15, there is an HPC on AWS titled Innovating Without Infrastructure Constraints. HPCGA will be highlighted in that session. So if you'd like to get a little bit deeper into that, I think it's a good opportunity to do so. Should be a good conversation. All right, so along the same lines, very excited to finally, openly announce the availability of a Milan-based instance, our first third generation EPYC processor instance type called M6A. It's general purpose, and these, rest assured again, it'll be followed by more instances moving forward, right? But this is the first time that we've had Milan live and available. And I was talking about how some things are just finally, getting done this morning. This is one of those examples. So there was a blog that was released already, and you will see other announcements and discussions for further keynotes down the road this week. What's exciting is compared to the existing M5A instances, M6A takes advantage of the new Zen 3 core for better price performance, more core density, to meet customer demands for increased scalability. M6A delivers at least 35% better price performance at 10% cost. All right? So there's some other elements to this as well. I did say at least. Of course, I'm always an eternal optimist in sales, as you have to be. But there's a lot more juice to get from that fruit, I'll tell you that. So what's other things of note here? So it's SAP certified. I think the workloads that people would expect are what you would expect for any general purpose workload, right? Certainly containerized applications, standard enterprise workloads, multi-server gaming solutions, caching fleets, app dev, whatever you want. I mean, it's going to be your workhorse for your environment. It's available in 10 sizes with 2 more instance sizes than our M5A, so our previous EPYC first generation Naples, which includes 32x large and 48x large. The 48x large has up to 192 vCPUs and 768 gigs of memory, which is twice that of the largest M5A instance and greater than the nearest M instance type. So in addition, it's built on Nitro, right? So you get the combination of the dedicated hardware and a lightweight hypervisor, which delivers nearly all of the compute and memory resources of the host hardware to the instances. So we believe this thing is going to be a beast. We're really excited about it. And, like I said, Milan launched earlier in 2021. we've been working really hard in conjunction with our partners in AWS and EC2 and trying to get this out to the public as soon as we could. So we're very excited about this launch. And like I said, more to come, a lot more innovation to come. We could not be more bullish about the partnership between the companies, for sure. So moving on. So we talked a little bit about EPYC. So it's codenamed Milan. You heard me mention Milan already. It's our third generation of the EPYC line. It's AMD's industry-leading data center product, which includes Infinity Fabric architecture and builds upon the strong foundation that we established with first and second. And again, this is first, second, third generation, right? And you think, again, how long AMD has actually been in the data center space. Really not that long. It's really not that long. You can see how fast things are improving with this company. It provides outstanding business value, enterprise IT, it really doesn't matter, and especially HPC applications. Again, I think with all of these, when it comes to performance, you're going to see the typical benefits you'd expect from an AMD data center processor. But along the same lines, the Infinity Guard architecture that exists as part of this, it's hardened at the core, and it features elements that allow you to run your sensitive applications in a virtualized cloud environment. I think there aren't going to be many conversations this week or sessions that talk about the Infinity Fabric that exists with AMD EPYC, but it's something I highly recommend you take a look at. There's discussions on SEV and SEV SMP, really forward-looking architectures that kind of change the game. I mean, really change the game when it comes to security at many levels. So with that said, a little bit more talk on this. So when you start to take a look at this, you just look at EPYC itself, forgetting about how it relates with AWS. But in general, it's 48% faster performance core versus core against the competition, okay? It's got greater density, more memory capacity than the competition, which allows you to make efficient use of the limited resources when it comes to data center space and power consumption. More importantly, you can pack a lot more VMs in per rack. I mentioned again the framework for the memory isolation methods and confidential computing. Again, I highly recommend you take a look at that. Lastly, providing for additional improvement in I/O capacity allows for massive scale-out scenarios and high-performance computing. Again, we're talking very, very large exascale style deployments with this technology. So from a broad view, what does it do? It's just flat out, I think it's the best server CPU in the marketplace. Third gen EPYC is simply the best that there is today. It delivers more performance, best-in-class scalability, and a very, very differentiated security model. It increases the AMD lead in overall performance per socket, which enables maximum compute density. It also delivers per-core performance leadership. So where does that end up, right? So why AMD EPYC for cloud? Well, what it does, most importantly, is it's cost effective, right? I mean, and when you look at the initial releases of Naples and Rome, so our first gen and second gen processors of EPYC, you'll notice a theme, right? So it's generally, I think the initial ones out were relatively the same performance for less cost, right? And when you start talking about general purpose workloads inside cloud, not a lot of downside. There really is no downside to that scenario, right? You save cost, you get the exact same x86 instruction sets. But you look at that cost, and also to mention that in India and Mumbai, there's 45% discount on that as well. So, talking about a migration and the ability to actually move workloads across country lines in order to save substantial amount of overhead is actually quite effective there as well. But what we also have is leadership in the ecosystem and solution availability. So as you'd expect, all of our CPUs on different instances, doesn't matter what they are all built on the same x86 instruction set as you would expect, right? And our solutions have been around for a long time. And it's the same instruction set. It's compatible with all Intel instances. Any workloads running in competitive instances can be easily run on AMD, which allows for that, example of, say, a migration across country lines for better discounts. And EC2 has worked extensively with AMD as part of this to ensure seamless compatibility between competitive instances and the AMD instances. But this is really important. I mean, when I say that they work extensively with us, and the quality of what they release is top notch. They don't release anything unless it's perfect, and that's one of the things we love about the relationship. So the same virtualization and hardware components are used, for our competition is used for ours. So it's the same thing. It's interchangeable. Again, it's the beauty of x86 architecture, and it's the beauty of having a quality product like EPYC where you can get exactly the same function for much less in total cost and a heck of a lot more density and performance. We also work extensively with operating system vendors, open source maintainers, many commercial software providers. Everybody, as you would expect, right? It's no shocker there. It's important for a product like this to be, have interoperability across the board without exception. So we're part of that same ecosystem that everybody else is. If you start talking databases, everything else, it's just a laundry list here they throw in front of me as far as notes. But, really, it doesn't matter. It's going to work or it's not going to work. I think the brand of AMD when it comes to this is starting to really take hold and people understand, how it's used. So when you use x86 and you use our product, there's no headaches, right? No gotchas. You know exactly what you're going to get. So we'll touch a little bit more on the enhanced security part of this as well, because I really do believe that this is a substantial differentiation. And I come from the virtualized software world, where I remember having conversations at Intel back in the mid-90s when we started building out massive data centers and application architectures. And it was difficult because application developers at the time, everyone was dependent upon a single system. You guys remember all the legacy systems, whether it was VAX or DEC or everything else that came up through the Unix world. They were all still monolithic in nature, right? And we even talked back then about building in virtualized layers across various communication architectures to try to avoid single points of failure, which is obviously you would expect in a fab is very important. Same thing here, right? As soon as you start to do that and you start to open up security issues, AMD has spent a great deal of time developing this technology around Infinity Guard, and have designed our CPUs for the data center from the ground up with security in mind. So we've had less breaches, less attacks than our competitors, and we have the data to back that up. Essentially, AMD technology is moving forward to allow customers to get more for less. The market's responding as they see more TCO. But if you want differentiation, really dig in to the security element of this. There's a lot you can take advantage of, especially for your developers. So if we've made tremendous progress with EPYC over the past 3 years, for sure, and certainly have with the relationship with AWS. Whether it's in exascale supercomputing, cloud services, or enterprise apps, AMD EPYC powers the world's most important workloads. Third gen, Milan, offers industry-leading core density, L1 and L3 cache, memory bandwidth, and capacity per socket, making it the ideal compute platform for running commercial and exascale HPC workloads in the cloud. As an additional note here, so up to 160 PCIe 4.0 compatible I/O lanes per socket enables massive fast storage, quintessential for data analytics and data sciences. And there's obviously these workloads vary quite a bit. What's interesting about this, you start to look at the stratification of this, and it's becoming fascinating how certain applications can take advantage of certain elements of CPU architectures, and some don't, right? Some rely purely just on the upper layers that are exposed naturally. Others actually take advantage of some of the natural benefits of various products. And when you start to really dig into some of these companies that are doing work in this space, they're doing amazing things, really amazing things, getting down to the guts and really taking advantage of where AMD EPYC shines, right? So there's a lot more to this than simply looking at Spec 17 or Spec 6, information and comparing between other products in the business. There's a lot more to it than just memory. There's a lot more to it than I/O lanes, right? And really, you're taking a look at the whole package. And right now, EPYC third gen really is the leader in the industry. So I talked a little bit about, again, these specifics around some of these various categories. So this deck, I believe this deck goes out to everyone. It should. But there are links in this deck to tpc.org that actually shows some of the data relative to some of the studies that were done in these various verticals. As a side note, I do want to mention that AMD held a launch update earlier this month. I think it was November 8th was the day. It was a Monday. It was called Accelerated Data Center Premier, where Milan X was part of the discussion. Now, there were multiple BUs across. Lisa Su was obviously talking, and there were a lot of products that were discussed. But Milan X, just to give an example of kind of how this evolves over time, Milan X took advantage is a product that's in flow right now, and it leverages AMD 3D V-Cache technology, which adds 8 CCDs to 64 cores, providing 768 megs of L3 cache per chip. And this is a game changer, and you're going to see a lot more of this type of innovation from AMD moving forward. So you'll see it as a chiplet design kind of methodology, right? And I got to tell you, when I was approached by AMD when I opened the door and said, hey, I'm open to different conversations now, I thought in a million years I'd never go back to a semiconductor company. It made no sense to me. I'm a cloud native guy. I'm in this space. This is what I love doing. Why would I want to go back to that? I had no idea. I had absolutely no idea how innovative technologies had become in this area. But really, what sealed it for me were two very simple things. One, you want someone to follow, you follow Lisa Su. Let me tell you something. That is an amazing, impressive individual. And not from just an operations perspective, just has a vision. And you see people that have a vision, and it's clear. And it's clear to them, but everyone else struggles to understand it. She's one of those people, and just really a fantastic person, all in all. So that was easy for me. I needed to make sure that my leadership was good, and that I believed in their vision and who they were as people. But the other part of it was, when I looked at the roadmap and started to get a feel for where the company was going, I really dug into the chiplet aspect of this because, in my simple brain, I'm not a I can't draw out a circuit board anymore. I think I got maybe a C in that class, I'm sure, in my undergrad work. But, when I think about it, I think about Lego blocks. And the thing about it is when you start to look at AMD and you start to understand the concept of chiplet design and 3D V-Cache and other things that will be coming, you start to understand that there are ways to integrate various functions and layers of IP, whether it's IP for AMD or it's IP for other companies. And there's a lot of stuff that can happen down the road, right? So it's not hard to imagine how you could see a company like AMD that starts to innovate in ways that no one's ever seen before, right? So I'm very excited, and that roadmap was key. That roadmap was key. But I really highly recommend you take a look at that Accelerated Data Center Premier. It was great. It's really well done and very informative, a lot more informative than I'm able to be, right? Because they're the big brains. I'm not quite there yet. So, going over some benefits here. I think the long and the short of this one's pretty simple. There's great TCO benefit to using our product right now and what's available inside AWS EC2. You can apply those TCO savings across the board and do various things, right? I'll talk a little bit about efficiency, I think, on the next slide here. But the ease of migration and the security stuff we've talked about, right? So x86 across the board, there's no difference. It's a better value, higher performance in many cases, especially based on certain types of workloads you take a look at. There really is no reason not to use AMD, especially when you start to understand, there's a lot more coming, and you're going to see a lot more things coming down the road. But the other part of this that I really also I have personal affinity for was, the company the industry really took a goal in 2014 to reduce the amount of power consumption, right? And AMD was very excited to reach that goal of reducing power consumption by, compared to perf, by 25x by 2020. And, the industry has taken on this goal that's already in place, right, of additional 12x in reduction and improvement. AMD has taken the higher goal of 30x. And this is also another area. If you are very curious about where the most innovative companies in the world are going, it's interesting having conversations with whether it's public cloud operators or it's hyperscalers, those that run massive businesses, massive data centers with a lot of data going through. You start to talk to them about, when we were doing these initial build-outs, say 2010, 2012, and even earlier, space was the issue, right? Space was the concern. You'd have these monolithic systems, massive amounts of racks, and you couldn't get enough network ports to deploy racks. You couldn't get enough space. Companies would be, eventually, well-known Microsoft starts building data centers inside trucks, right? And they're dropping trucks all over the globe. And I remember being part of that project. It was fascinating. I couldn't believe they were doing it. And they're just throwing the trucks away, right? So, but that's a space constraint issue. Now you're going to start to see this constraint being power, right? You start looking at over time, you think about the concept of Moore's law being dead. It's dead to some degree in the sense that in the way Gordon defined it early on, but it's not when you really start thinking about the amount of compute required in order to do all of the amazing things that we're seeing, right? We have Meta starting to come out talking about the metaverse, and you start, if you think about it, you think about how much compute that takes, right? Aside from the acceleration part of it, who's providing what when it comes to that infrastructure, you think about just the amount of workload required to generate that type of environment, and just the communication between those environments. It's tremendous, right? And if anyone here thinks that load's going to go down at some point, if that load goes down, we're all in trouble. There's something else going on, right? It's not a computing issue, right? It's a world issue going on. So AMD is a front runner here, and especially in the area of HPC, which is just a hog. It's an absolute hog for power. And so we take this very seriously, and you're going to start to see a lot more innovations around this in the near future. So it's something that's that's worth getting behind. So also last year, I think we did announce the Cloud Cost Advisor at reInvent in last year, maybe it was 2019. But it's a do-it-yourself tool for cloud admins in the enterprise to get real-time insights into estimating the cost savings by considering various AMD workloads. I don't know if the latest generation's incorporating on that yet. I didn't have a chance to look at the debrief to see if there were any changes to this tool. Imagine it will be very soon. But you can do a lot of things, and I'm not going to go through all the various things you can do on it. I mean, it's kind of what you would expect from a classic tool. You put in a bunch of information in there, and it generally tells you based on what you're trying to do, what you're looking at. But one of the cool thing about it is it's got a greenhouse gas emissions calculator that's in there as well. And I think that part of it is one of the best things you can look at as well, because it really is interesting. You start to take a look at our choices as application developers and how we're actually getting from point A to point B, how we're actually computing everything we need to get to, and what the impact is internally to the company that's hosting, and what the subsequent impact is to the world, right? I mean, you really have to start thinking in those terms, right? I mean, the world is limited. Time is finite. Time is infinite, but the world is finite, right? So we have to be very careful about that, and it really is very eye-opening. You start looking at it, and you start looking at various services. You can start looking at various instances and start to say, okay, what is the environmental impact here? Right? It's a fascinating thing to go through, and it's something that everyone really should keep in mind. Keep top in mind, whenever we're having these architectural conversations, right? What's the impact to everybody else? There's some videos that are out as well too. I think it's linked in this deck, which you'll be able to see when it releases. So this is, the vertical examples here. We hear from customers every day. We've got a great example from Blackboard recently. They saw a cost reduction of 28%, using our technology, right? And they were able to reduce their costs, in a time when it's very difficult, right? So they were very appreciative of the savings. WeGo had a similar example. We've got a whole bunch of different companies that come through and do various studies with us and talk about testimonials as you expect using our technology. So I highly recommend you take a look at this too. It's worth the time. And one of the things I do love about this, we do a really great job at AMD. AWS does a fantastic job on testimonials. We're going to be producing more about how AMD Milan, how AMD EPYC 3rd Gen inside AWS is really benefiting customers. And we just had to get it out there first. And now that it's out there, we'll start actually doing testimonials against it. So we have a whole bunch of customers already lined up. Can't wait to do that. So it's a great product. But I highly recommend you take a look at it. Again, the links are included in this deck. And it really is, it's emblematic of how AMD can benefit companies, even when they don't think they can. So we start talking about the roadmap. I talked about the vision a little bit. I talked about what really excited me about the future. Fundamentally, when you take a look at our Zen 2, Zen 3, Zen 4 architecture, and you look at our manufacturing process and how it's moving over time, obviously, we've got a next gen that's coming at some point here. In 2022, there will be a release out of Zen 4 in a 5 nanometer design, and we're very excited about that project as well, and really excited in deep collaboration with AWS and others in this, and you'll see the same type of improvements in performance, the same type of improvements in density and cost perf We're very excited about that. You know, again, it's why I joined AMD, and the best is yet to come. So with that, you know, we've got resources here. Of course, obviously, we pointed out the Cloud Cost Advisor. We do also have a proof of concept fund that we can explore. At the very bottom there, AWS at AMD.com. That goes directly to my organization. So just if you have any questions at any time through any of this, how to use any of this information, how to get access to stuff, or you just have questions on you know, deployments, you know, future offerings, anything you ever want to talk about, send it our way. We'll get back to you, right? And you know, I think the part about the POC fund is really good. Is that, you know, I mean, it's what's the downside, right? What's the downside? You have an idea, you want to do something, you think it actually might be able to benefit your company, and you think it actually might be able to save money at the same time, a little OpEx. Why not? Well, why not go down that route, right? So we've got funds for that. We've got organizations dedicated to helping that. And of course, obviously, this would all be in conjunction with AWS, who is fantastic at doing these types of things. So again, I highly recommend you take a look at all of the material that's linked here. And with that, I'd like to say thank you. Thank you again to AWS for hosting this. It's fantastic. I love being in person again. Thank you for everyone here for taking the time. Very much appreciated. And then, of course, you have to, you know, I'm not sure if the surveys are coming via the app. Yeah, they should, right? So please fill out the survey. Love to hear your thoughts. And again, you know, I'm not the speeds and feeds guy, right? So if you want to come here and, you know, you want to come here and debate power or the best performing elements in the world, I'm not the right guy, right? I'm just going to say, okay, that's great. I can talk to this guy, right? So it's okay. But we do have a Q&A open right now. You know, whatever I can touch on, you know, again, like I said, I've got views across the entire industry. I've been doing this a very long time. And anything related to this, you know, let me know. Appreciate the time. Thank you, everybody. So we have any questions? Any thoughts? Tomatoes?
When do we buy the AMD bin?
That's awesome. That's awesome. Well, I hope you don't see one anytime soon. I know, it's insane. You know, what's interesting about, I mean, there's a whole bunch of stuff on that, right? But yeah, I think what the market is starting to recognize is that we're not tied to a desktop processor ebb and flow, right? This is not where we're at. And that's one of the fascinating things. When you go back and on November 8th, you take a look at that, you'll see just how diverse this company is. I mean, it's really impressive. I was shocked. I quite frankly got shocked. I had a totally different view of the company before I joined. You start to look at the things that we're in, all the things we mentioned, whether it's data center or it's GPU. And we didn't talk at all about the GPU business and the GPU in the cloud, right? We've had incredible innovations there, aside from everything else. So yeah, I'm with you. I'm with you. I'm a buyer. I'm a buyer.
Are you guys mostly with AWS or also like Azure and
Yeah, so we have relationships with Azure and GCP, as well as others in China. Yeah.
You gonna have any disk-based units?
I'm sorry, any what?
The I instances. I'm waiting on I instances.
Yeah, I know. I'm with you, brother.
Question about disk-based variants of the NVIDIA.
Yeah, an I instance. Yeah. So. But that'll probably change.
Send this guy email.
Look, seriously, you know, it's funny. That email address right there, send it our way. It helps. It helps, right? And because, again, we've got a great relationship. AWS is fantastic to work with. And they're just tops of the tops, man. It's just amazing engineers and leadership there. I have loved working with Amazon as a company. You know, I've been blessed to be able to work with a company like that for so long. They're fantastic. But you know, part of this is making sure that we can collect the information so we have enough companies that can say, look, yeah, we do need this, we want this, because we know we shine. We know we're going to shine an eye, right? We still have to make that case a little bit. Any pressure you can help put on them, that helps. Thank you.
When will
Uh, yeah. Yeah. And that's pretty typical, right? I mean, it's pretty typical. It's a very small initially footprint. Make sure there's no issues, right? And then roll out in general. So yeah, you'll see it follow the same pattern that you've seen over everything else. No, really can't. And what I can say is that we're in a lot of conversations. Like I said, I refer to AMD as Lego blocks, right? So part of the problem sometimes is we have a lot of blocks. So we're working through that right now. But I think, like I said, I really honestly believe that the companies we're hitting our stride. So you'll see the acceleration pace increase between the two companies. That I assure you. Where it ends up landing, I'm not sure yet. But there's a lot of conversations going on in many different arenas. Anything else? Yeah, so the way to look at Milan right now is we had our first and second gen, but this really is, in my opinion, it's the first good front-facing. I'm not saying the other ones are great, but just it's what it needs to be, right? So this is where I consider. I look at that. This is the base by which we start building inside EC2. So yeah, our expectation is there'll be more instances at release, right? So of course, HPC6A has to still officially go GA, and of course you would expect the other, other potential instances launching after that, right? So it just kind of depends. And the reason why I don't bring it up is, plans change too, right? So sometimes you start having conversations about a next-gen architecture that's coming very soon. That might actually supersede the need for an instance based on Milan. So you never know, right? So there's a lot of flux in there. And AWS is very good about being cautious with that because things change. Now, the relationship and our AMD presence inside AWS moving forward, yes, it absolutely will grow. That I can tell you, it will grow. Great question. Anything else? All right, very good. Give you guys some extra time. Appreciate everybody. Thank you very much.